Okay, so in this example, I want to, for the following function, show there exists a c with 0 is less than or equal to c is less than or equal to 1, such that f of c is equal to 0. So I want to show there exists some c in between 0 and 1, such that f of c is equal to 0. Alright, and so this alerts to you to use the IVT. Now we need to be careful here, and we need to first check that our function is actually continuous on 0 to 1. Alright, so the question here is f of x continuous on the interval 0 to 1? Okay, and so I'm hoping all of you would say yes. Right, because here we know that polynomials are continuous on all real numbers, right, because the domain of polynomials is all real numbers. And so we said that all the functions that we've studied in our life besides piecewise functions are continuous on their domain. Alright, and so since we know that the domain of a polynomial is all reals, we know it's continuous on all real numbers. And so of course it's continuous on the interval 0 to 1. Okay, beautiful. So now I can proceed. And what do I need to do to show that there exists a c in this interval where f of c is equal to 0? Well, I need to check that f of a is less than 0 and f of b is greater than 0, right? So I need to check so now I need to check that f of 0 is less than 0. In other words, check that f of 0 is negative. Okay, so we have that f of 0 is equal to 0 cubed plus 0 squared minus 1, which is equal to negative 1, which is less than 0. Okay, so that requirement's met. Now I need to check that f of 1 is greater than 0. Okay, so in other words, I need to check that f of 1 is positive. And so f of 1 is equal to 1 cubed plus 1 squared minus 1, which is equal to 2 minus 1 equals 1, which is greater than 0. Check. Okay, awesome. So now what can I say? Well, I can say then by the corollary to IVT, or just by IVT, I'm just going to say by the intermediate value theorem, we have shown there exists a c in, sorry, I forgot you guys don't know what that symbol is. C in 0, 1, such that f of c is equal to 0. Okay, so we've shown that.